so that's it for hyperbolas. Let's go to Chunkus. So the most common form of a Chunkus is f of x is 1 on x squared. And it's always positive. So you don't have, unless you have like a negative in front of it, it's not going to be below the y-axis, below the x-axis, sorry. It also has asymptotes. So for this one, it has an asymptotes at x equals 0 and y equals 0. So similar asymptotes to a hyperbola. So here's what it looks like. So you've got asymptotes, so horizontally, and you've got vertical asymptotes as well. It has a general formula, so you've got f of x equals a on x minus h squared plus k, and you've got an asymptote at x equals h here, and y equals k here. And keep in mind, same as before, that a is your dilation, so squish, stretch. If a is negative, it means it's reflected. A few exam tips. So when you sketch asymptotes, make sure you use that dotted line, use a ruler. And even if the asymptote is on the axis. So for example, if you have something like this, so let's say you've got y, you've got x, and your graph is y equals 1 on x. Your asymptotes are y equals 0, x equals 0. So when you're using a pencil and you're drawing on that black line, it might be hard to see the asymptote. So what I like to do is I like to draw it slightly to the side so you can see the markings I made and label it clearly. So x equals 0, and then slightly to the x side, extend it a little bit more so it's very easy to see that you've drawn an asymptote, and here you've got x equals 0. Okay, so use that dotted line to sketch an asymptote, and never let your graph touch the asymptote, because you know that if your graph touches the asymptote, you've drawn it wrong. So always approach it, so get closer and closer and closer to the asymptote, just never ever touch. Okay, so that's it for Chunkus. Let's do an example. Actually, I think it might be a good idea. I'll just make up an example now. So let's do a simple one. So if you know how to draw hyperbolas, you know how to draw Chunkus. So the principles are essentially the same. Okay, so let's do y equals 2 on x minus 1 plus 1. Okay, so we've got y, got our x. Okay, use this. Okay, so our asymptotes, x minus 1. So we've got an asymptote at x equals 1. And then we've got another asymptote at y equals 1. Oh, sorry, this is y equals 1. We've got an asymptote at x equals 1, which is probably around here. Asymptotes and the Chunkus will look like this. Approach the asymptote, and same on the other side. Okay, if you have a negative graph, so let's say we've got y equals negative, so we've got y equals 1 on x squared. That looks like this. X, y. It's going to go look like that. So again, these graphs are not perfect. I just want to show you the position of the graph. That's it. So I'm not trying to show the shape of the graph, or I'm not trying to make it accurate here. I just want to show you the position. If you've got y equals 1 on negative 1 on x squared, your graph is going to be reflected. So you've got y, got x, going to be like this now. And that's it. Okay, so next concept is square root functions. Square root functions are basically a function, as the name suggests, function inside the square root. So for example, you've got f of x is square root of x. It's unidirectional, it starts at 0, 0. So I'll show you an example of how it looks. We've got y, x, you've got an endpoint at 0, 0. and it goes like this, one direction, just on the right. And the reason is we can't square root negative. So you actually cannot have a square root on this side because you can't do square root of negative values of x. You can square root 0, so that's why you have this 0, 0 starting point. So essentially our domain is x is greater than or equal to 0. So x is from 0 included to infinity. If you have f of x is this, so this is our general form. So this is our general form. We say x is greater than or equal to b because x minus b greater than or equal to 0. And the start point is BC. So these are our starting point, BC. But if you have f of x is negative square root of x, so negative, so square root and then inside negative x, then negative x is greater than or equal to 0, which means x is less than or equal to 0. So the graph will look like this. So we've got y, got x, go, and this way. So that's the way it's going to look. So essentially here, if you have a positive x value, so if let's say x is negative, if x is 4, you can't do square root of negative 4, but you can do square root of negative 4, which is just square root of 4. Okay, so again, back to the general form. HK, that's our endpoint of the square root. And they're also horizontal and vertical translation. So the endpoint can move up, it can move down, it can move to the right, it can move to the left. If a is less than 0, the graph is reflected over the x-axis. If b is less than 0, it's reflected over the y-axis. Okay, so let me just draw a graph to show you what's happening. So we've got y, got x, and I'm just going to use different colors to save time. So let's start with our basic graph. Starts at 0, 0, so all of the graphs are starting there and going this way. So this is y equals square root of x. So and it's going 0, 0. You've got another graph. Let's say you've got the graph this way. This is y equals square root of negative x. So we talked about this earlier. Another graph. So let's do it purple. So they're all starting here. Here, this is y equals negative square root of x. And lastly, we've got, let's go green. Here we have y is negative square root of negative x. So that's how we draw these graphs. So hopefully it's straightforward. You can see sort of the pattern of what's happening. Okay, square root, that's it. So circles, circles aren't a huge part of 3-4 methods. They might come up just sort of like general knowledge, but it's not really a big part. The general rule for a circle is this. So you've got origin of 0, 0, so starting at the center. R is the radius of the circle, so how big is the radius? So here we go. So this is the length of R. Your origin here is 0 and 0. And your radius, yeah, is 1 here. So you can see this equation. 1 squared, that's a radius. The general equation for a circle, so HK, that's your origin, or that's sort of your center, and R is still the radius. Oh, this is wrong. It should be equals R squared. Okay, sorry about that error. It should be equals. So R is the radius of the circle. So remember, R squared is not the radius, it's just this R that is the radius of the circle. Okay. So that's it for circles. It's not a big part of the study design, so I don't think there's much point in going through them in depth. So let's go to domain and range. So these are really, really big parts of the study design. So domain of a function, so that's the set of the x values that the function will work with, so that the function can actually take. So it's your input of that function. And the range is your output. So basically, depending on what x's you put in, what is the output of the function. So all the y values that you could possibly get with that function. So if the function is f of x equals x squared, the domain is R and the range is 0 to infinity. Okay? Always a curly? No, always a round. 0, so you've got y, you've got x squared, so like this, something like that. Okay, so x can go either way forever. So it can go negative infinity, positive infinity, forever. But y starts at the turning point of 0, 0. So it includes the turning point and then goes up forever. It doesn't go down. So that's why the range is from 0 included to infinity. And make sure that you remember, infinity always has a round bracket. So negative infinity is round bracket. Infinity, round bracket. So keep that in mind. Sometimes we get rid of this part of the function and only write the rule. And that's because the domain of that function is sort of implied. So if I tell you here f of x is square root of x, well, the domain is implied. It's implied that it's from 0 included to infinity. The maximal domain of a function, so that's a word that you'll hear quite often, so maximal domain. And that's basically the largest set of x values where the function actually exists. So what x values does the function exist? So let's talk about the quadratic before. So if you have f of x equals x squared, then x is a subset of all of your numbers, because x can exist for any x value. But if you say f of x is a hyperbola 1 on x, then x is a subset of all of your numbers except 0. So based on that equation, what values can the function exist for? So that's your maximal domain. So let's do an example. So find the maximal domain and the resulting range of the following. Here, it's a good idea if you want to pause and have a go at it yourself, but I'll just get onto it. So f of x is square root of 3x minus 2. That's equal to square root of 3x minus 2 on 3. So the starting point, so your square root graph will look something like this. So starting point is maybe here. So 2 on 3 and 0. Go up like this. Okay. So here we can see the domain. So the domain of function f equals 2 on 3 to infinity. So keep in mind it's a square bracket because we're including that endpoint, because it's a closed circle. We're including that endpoint. Okay, so now the range of f equals, so it's starting from 0 to up. It's going up forever. 0 to infinity. Another way you can write that is all positive real numbers union 0, including 0. So you can write it either way and you'd still be correct. Another example. So for this one, again, you can pause if you want to have a go at it. So now's a good time to pause. So to do this one, you want to find the maximal domain. So you've got f of x equals square root of 1 minus x squared. To find the maximal domain, let's rewrite it into a formula. So f of x equals negative, square root of negative x squared plus 1. Okay, so this is a bit more tricky. Negative x squared plus 1. Negative x squared plus 1 should be greater than or equal to 0. So how does this graph look? Well, you've got your y, got your x, y-intercept of +1, and negative, so it's going to go this way, going to go this way. And we want negative x squared plus 1, we want that graph to be greater than or equal to 0. So from here to here is what we want to include. So these points, so this is -1, 0. This is 1 and 0. So those are our endpoints. And so the domain of this graph, x is from -1 to 1. So the domain of this function is -1 to 1. So it's a smaller domain here. So again, this is a little bit trickier, but essentially you want to see when the inside of this is greater than or equal to 0. And it's greater than or equal to 0 for this interval, so above the x-axis, and for this domain. So that's how you'd figure out the domain for this one.